Hello and welcome to a tutorial for the lenses simulation on my website. And when you open it up, it shows you ray diagrams for a convex lens. And if you just grab the top of the arrow, you can move it around. You can get all sorts of, you could show kids a magnifying glass, or you could show kids a movie theater where you start with a small upside down film. And if we zoom out, you can see it on a large screen. So yeah, if you adjust the scale slider, you can zoom in and out. If you use up and down on the keyboard, it also zooms in and out. And if you grab anywhere else, you can just translate the screen. If you want to reset the scale and everything, just click on convex again and it will reset everything to its initial values. You can also just flat out adjust the focal length of the lens, which adjusts the curvature. Or if you like, you can adjust the index of refraction of the material, which will also change the focal length. I'll just click on that to reset it again. If you go to the buttons on the left side here, if you click on pick, it removes all the rays as well as the image, and you could take a screenshot if you wanted and cut and paste that into a worksheet. If you click on face, it changes the arrow to a face, which may or may not be more interesting to your students. If you click on values, it gives you the values if you're using the thin lens equations to compare. And if you click on 1 centimeter snap, it only lets you choose exact to the centimeter heights and distances of the object and focal lengths of the lens. But of course, the distance of the image and the height of the image will also be decibels. Those will not be exact centimeters. So those are the options in the convex mode. If you click on concave mode, it's all the same stuff, just with a concave lens now. Moving up to eye, the purpose of this was to show accommodation of the eye lens and getting that light to focus on the retina, which is this red bar at the back of the eye. And the idea here is that if you move it anywhere within the two limits, you can see the lens will automatically change shape for it to be focused on the retina. But if you move that object too close, the lens cannot get fat enough, and so the image is focused behind the retina, and you have hyperopia or farsightedness. Likewise, if you move it beyond the outer limit, the lens can't get thin enough, and you have myopia or nearsightedness. That is eye mode. If you click on lab, this is kind of a sandbox for the kids to play around with. And there's a ray box here, which you can move. You can also expand it if you like. You can also rotate it. And you can change the number of rays up here. You can shine rays in from the top and get total internal reflection. It's an idea of some of the things you can do. You can translate the whole screen, as we talked about before, or you can drag the lens off the axis if you want. You can rotate it. You can see these dots represent the focal length and twice the focal length. And you could expand the size like that, but it will get more and more curved the larger you make it. So you can adjust the curvature here, or you can also change the index of refraction. Now, you can put on, I'll add 5 rays. You can put on other lenses. If you want to remove this lens, you just click on it there and it will remove it. If we want another lens, like a concave lens, you can just click on it and drag it onto that principal axis. You can use 2 lenses at a time if you want, which is perfectly fine. If you're going to do this, though, just be aware. Let's get these centered on the principal axis there. If you're going to do this, be aware that if you want to change the focal length or the index of refraction, whichever one is currently highlighted with the check mark, that's the one you're changing. So I can make that lens thicker or change the index of refraction. If I want to change this concave lens here, you just click on it and you'll get the check mark there, and then your adjustments will apply to that lens. You can add a third lens as well if you want. You can play around with that. If things start to get kind of wonky, you can always click on lab again and it will reset everything to the initial locations. Okay. You can also have a kind of a rectangle here, and I'll show you how you might use this in a minute with some of the presets. The rectangle doesn't play as well with the simulation as these other lenses, so you can't have both at the same time. So if you click on one of these, it removes the rectangle, or if you click on the rectangle, it removes the concave and convex lenses. The other things up here on the right, you can see it's currently on ray box. If you click arrow, this is kind of the standard ray diagram arrow, and you can get regular ray diagrams. Now, be aware that the height of the arrow in relation to the size of the lens will change whether you get ray diagrams that match what you expect. So if you do a convex ray diagram with an arrow at twice the focal length, the image will not necessarily be at twice the focal length if the object is too high, in which case there's too much curvature of the lens. But if you change the height of the object, you can get the image to be right on that location. And you can show all of the same ray diagrams I showed before. You could show, a magnifying glass, or you could show, this would be maybe we'll move it back a little bit further so we can fit this on the screen. This would be like a movie theater where you start with an up-down film and you get a large image up there. So those are some of the options with arrow. If you click on triangle, this is more of a two-dimensional object. You can click it in the center to drag it around. You can rotate it. And you can also change the size if you want to. Now, because of the small imperfections in where the rays hit the lens, you may not get a perfectly symmetrical image. Like you can see this line at the back of the image, although it is magnified, it doesn't line up perfectly. If you play around with the ray spread, which is the spread of the rays from the vertices of your object, you might get something that is more accurate. So that's another option. Finally, if you go down to the bottom here, there are a bunch of presets. If you click on eye, it just puts in this third lens, but it makes it look like an eye. There's a retina here at the back, but other than that, nothing else changes. You can still rotate this lens or whatever you like. Okay. If you click on myopia, it simulates the use of a corrective lens to correct for myopia. So we've got this lens here. If you move it down, you can see that object is getting focused in front of the retina. And if we add this concave lens and you can just kind of play around with it, you can see it will get that image. You can see it's slightly diverging the rays before they get to your eye lens. If the spread is too big, they might pass over the lens. You can see that these rays are passing over, so my simulation doesn't know how to draw the image properly. So just be aware. You can reduce the spread to its smallest, and then this will look right. But if you're getting that and you don't know why, it's because the ray spread is too large. Similarly, if you pick hyperopia, it's also showing the use of a corrective lens. So you can see without that lens, the image is being focused quite far behind the retina. And we introduce that lens, and it's more centered on the retina. Another preset is fiber optic. And this is the use of the rectangle. And you can see that, well, the rays are coming in and they're experiencing total internal reflection at each end. The final preset is for apparent depth, which places a triangle object inside a rectangle of water. You can see I made the index of refraction 1.3. And you can see that where these exiting rays, where they seem to have come from, is shallower. So we get a shallower apparent depth than the actual depth. And those are all the ways that I use this simulation. I hope you find it useful.